Okay, so good afternoon to everyone. Let's start today's session. So basically today we will see about the programming of the knapsack problem. So already I have discussed in the class about the knapsack problem, though this concept is necessary to do the program. So that's why I will again explain it. So basically knapsack problem states that we have maximum, there will be an object present, number of objects will be present, and each object has the profit and weight given. Each object has its own profit and its own weight. Now this knapsack problem is the optimization, and we call it is the optimization and maximization problem. Basically the approach, we think that we must fill the bag with smaller things, that there will be a bag present. Now this bag is the capacity and this bag has a capacity. Now we have to fill the bags. In this bag we have to fill the objects in such a way that we can get the maximum profit. This is the approach. But the approach, we think, basically is to fill the bag with smaller things. And if we fill the bag with smaller things, then we can put more items of the bag and we can get more profit. This is the approach we thought, but this is not the case. To fill the bag, we have to put the items in such a way that which item has the maximum profit per weight. Or we can say the right approach, that we should select the object having highest priority by profit, not priority, highest profit by weight. That means per kg, which profit is highest, we should take that first. Like this, we will do the approach. So let's see, here it is given, here it is some objects are given. So total, we can see that here 8 objects are given. And this 8 objects has its own profit and weight. So here the profit of the first object is 7 objects are present, and the first the profits are given. For the fourth object it has 7, for the fifth object it is 6, for the sixth object it is 18, and the and the seventh object, it has a weight 3, profit 3. Same as that for the weight also, the weight is given that for the first object weight is 2, second object weight is 3, third object weight is 5, fourth object weight is 7, fifth object weight is 1, sixth object weight is 4, and the seventh object weight is 1. So that's how the profit and weights are given. And we have a bag given, and this bag has the capacity. It can take intake capacity is the 15 kg. Now we have to put the items in such a way that we can get the maximum profit. How we can do that? We will see. We have to make that profit by weight. Profit by weight, which will be the maximum, we will take that first. So first we will check profit by weight. So for the first object, profit is 10 by 2, that means it is 5. It is profit by weight. If we check that, it will be 5. Then for the second object, you see 5 by 3. So it will be 1.6. Then for the third object, profit by weight 15 by 5, it is 3. Then the fourth object, profit by weight 7 by 7, it is 1. For fifth object, profit by weight, so 6 by 1, it is 6. For the sixth object, profit by weight will be 18 by 4, and it will be 4.5. And for the seventh object, profit by weight, that it will be, the value will be 3. According to the table it is given. So here, if you see, if you observe which object has the highest profit by weight, the highest profit by weight is the sixth object. So highest profit by weight is of the sixth object. So fifth object. So that's why we will take the profit by weight first for the fifth object. So we will include it fully. Now this fifth object we will include in the bag fully. Now, what is the of this? The weight is 1 and the profit is 6. So 1 means what? Our bag capacity is 15. We see our bag capacity is 15. And we are taking this fifth object fully. So that means 15 minus 1. So after taking this, it will become 15 minus 1, and the weight will be 15 minus 1. So the weight, it will become 14. So now after taking taking the fifth object into the bag, our total weight is 14 now. Okay. So next we will check which has the highest profit by weight capacity. Next, for the profit by weight capacity, the next highest profit by weight is for the first object. If you see, if you observe, first object has 5 value. So that means next we will take the first object. The first object we will take next into the bag. So the first object, if we take the first object, then what is the weight of the first object? The weight of the first object is 2. So that means if we take fully, first object, if we take fully, so that means the bag, its weight will become, the total capacity of the bag will become 12 now. The weight capacity of the bag will become 12 now. Next, which has the highest profit by weight? If we see, the sixth object has the highest profit by weight. If we see that the sixth object has profit by weight 4.5, that means we can take this. So if we take this and include it into the bag, then what is the weight of it? The weight is 4. So that means the next, if we take this into the bag, so in the bag, first we take the sixth object, then the first object we have taken, and after that, first object for first time, fifth object we have taken, the next first object we have taken, and after that the sixth object we have taken, and it is put into the bag. So the sixth object is 4. So it means the capacity will of the bag will now become 8. The next, Which capacity we will check? Now you see, both have, if we see that both this seventh object and third object, both have the capacity 3 and 3. The next highest capacity, both have 3 and 3. So that means what? You can choose anyone between this, anyone. So I have preferred that I have choose the third object first. So I have include the third object into the bag. And the total weight become what? The third object weight is 5. So that means after taking it, the capacity of the bag becomes 3 now. The capacity of the bag becomes 3 now. So that means the third object we have already taken. So the next highest profit by weight is what for the seventh object? The next highest profit by weight. So the next object, that means seventh object, we will include into the bag. So then we will see what is the weight of it. The weight is 1. So that means now after including the seventh object into the bag, our weight become 2. So that means first we have included fifth object in bag, then first object we have included into the bag, then sixth object we have included into the bag. After that, third object we have included into the bag, and then the seventh object we have included into the bag. So after that, which we will check now, our remaining capacity in the bag is 2. So the remaining capacity of the bag is 2. So now we will check what is the next highest profit by weight. So the next highest profit by weight, if we see the next highest profit by weight, that is for the second object. The profit by weight capacity is 1.67. Okay, so this is the our next highest profit by weight capacity. But the problem happens here because the second object weight is 3, but the remaining capacity in the bag is what? The remaining capacity in the bag is only 2, but its weight is 3. So we cannot take full weight of this object, and we cannot add this object fully because this object's weight capacity is 3 kg, but in the remaining of the bag capacity is what? Only 2 kg. That means we cannot take the whole weight. We have to take the fractional weight. So fractional weight means between of this 3 kg. How many we can take of this 3 kg? We can take only 2. So two-third of the second object we can take. So two-third of the second object we can take because 2 is remaining. So and its weight is what? Its total weight of the second object is 3. So that means 2 by 3 portions of the object we can take that. So if we take this into the bag, then in the fractional weight, if we take that, that means the total capacity, two-thirds of this, if we fill it into the bag, then our total weight will become 0 now. So the solution of the problem will looks like this. With the solution of the problem is what? The solution of the problem, we will see that it looks like that. So first object, you see first, its weight is 2, then 3, then 5, then 7, then 1, then 4, then 1. So that means first object, where x1, it is of 1. Then second object we are taking, so the first object weight is 2. So the first object we are taking fully, that's why we placed it as 1. Now second object weight is 3, but the second object we are taking two-third, the two-third of the second object. So that's why the second object is two-third. For the third object, the third object we have taken fully and its weight is 5. So this is totally taken. Now the fourth object, no, we didn't include this fourth object into our bag. This fourth object, we didn't include it into our bag. Its weight is 7. So that's why we put 0 here because it is not included into the bag. Then the fifth object weight is 1. And yes, we have taken fully this fifth object, we have taken fully. That's why we placed it as 1. Then the sixth object weight is 4. And sixth object is also taken fully. So that's why we are placing 1 here. And the seventh object, this seventh object also we take fully, and that's why we have placed it as 1. So that means now if we calculate this, then 2 into 1 plus 2 by 3 into 3, then 1 into 5, then 0 into 7, plus 1 into 1, plus 1 into 4, plus 1 into 1. If we total calculate this, then we will get the total capacity of the bag, and we have the value. See, we have the value we get, that the value we get is 15. So that means this total weight, and if we take like this, the objects we have taken like this, then the capacity of the bag can be full. Same as that, if we have to we have to get the profit, then what we will do, then according to it, we will see the profit of it. So profit will be what? Then it will be 1. So 1 into what profit is given for the first object. We will see the profit given for the first object. The first object profit is given 10. So that's why here it is 1 into, we are taking 1 into 10. The first object profit is 10. Same as that, for a second object, we are taking 2/3, and the second object 2/3 we are taking, and its profit is 5. Then third object 15, fourth object 7, fifth object 6, and sixth object is 18, and seventh object is 3. So that means same like that, we will make the profit. So 1 into 10 plus 2 by 3 into 5, then 1 into 15 plus 0 into 7, then 1 into 6 plus 1 into 18 plus 1 into 3. So according to it, if we see, then we can get this profit 55.33. So this is the maximum profit we get. So this is the approach. This is the approach or the way we can put the values in the bag. It is clear to everyone? I've already said into the class, but though I will use it into the program, that's why I again explain it. It is clear?
Yes, sir.
Okay. So now that means, so we will now move into the programming concept. So we will move into the this knapsack. We will move into the programming concept now. So how the programming of the knapsack can be done, we will see that. So first, let's say we will use hash include stdio.h. So this is the header file we have taken. Now, after that, we will use, let's say, main functions. We will use int main, and inside it. So first, what we have to take? The first we have to take the number of elements. The number of elements we will use. So that's why we are using, let's say, n is the number of items or the number of elements. So that means we are declaring int n. So we have to use printf function, because n is the number of items that is present. So it is, let's say, we are stating that enter, we are saying, sorry, enter the number of items, the number of items. So same as that, now we are taking this as the user input. So scanf function should be used. So scanf, we have to take this %d and ampersand n. Okay, so we are taking this input. So number of items we are taking as a user input. Now what we have to do? Then after that, we will declare two arrays. One is value, or we can say profit also. That is up to this, but we are saying that it is a value. I am declaring it as a value. And another is int weight. Int weight. So this is the, we are saying this is two arrays we are taking. One is value and another is the weight. So that's why the value and the profit and the weight will be shown. So we'll take the values as the profit, and the weight will take the weight of the each items. So that's why we are using the array. Then after that, let's say int I, we are saying, then again we are using a printf function. So printf, we are saying that enter the items, let's say items weight and its value. So enter the items weight and its value. We are taking this. So enter the items weight and its value. After that, what we will do, we are taking this as an array. So that means a loop has to be used. A loop has to be used, and one by one in the index, the value will be stored. So that's why we have to use a loop. So for I equal to 0, I less than n. And so we are starting from 0. So that's why we are using I less than n. If we start with 1, then I less than equal to n. We can write in that time. So I plus plus. For I equal to 0, I less than n, and I plus plus. Then scanf, we are taking two values. So that's why we have to use %d, then %d. Two values we are taking as a user input. So %d, comma, we have to take the weight. We have to take the weight and the value. So scanf, we are taking the weight and the value. We are taking that. After that, now we have to use, this is a, we are taking this. Now we have to take the capacity of the bag. The capacity of the bag is also has to be taken. So that means we will use a variable, let's set w. We are using w, and printf saying that enter the capacity of the knapsack. Capacity of the knapsack. So that means this will be the capacity of the bag. So enter the capacity of the knapsack. This is the for the capacity of the bag we are taking. Enter the capacity of the knapsack. And this is also we have to take as a user input. So that's why we are stating that ampersand W. Okay, so the capacity of the knapsack we have taken now. Now what we have to do, we are saying that printf /n maximum value in a 0-1 knapsack. In a 0-1 knapsack, the maximum value in a 0-1 knapsack is %d/n. Maximum value in the 0-1 knapsack is the %d/n. And let's say we are saying that this functions, there will be a function that is knapsack function, knapsack, and it will contain w, weight, value, and n. So we are saying that the maximum value in the 0-1 knapsack will be, if this functions, this is a function, this function will produce the maximum value in the knapsack. So we are taking here we are calling a function, that function user defined function, that function name is knapsack, and it has the parameter w for the weight capacity of the knapsack. Weight is the weight that is given, and for this the profit, that particular profit, and the n is the item. So this is the function, and these functions will give the maximum value in the 0-1 knapsack. Okay, so that means this is the function we called in the main function. So that means this function has to be declared or defined. So we will, after that, we will define this function. So this function is called into the main, inside the main it is called. So that means this function has to be function definition. So we have to define this function now. So let's say this will be 0 and there will be the final. Okay. So now we have to declare this function. We have to define this function. So let's say now we will define this function. So outside main, we will define this. So now we will use int knapsack. It is w, so that means it is same. It will be int w, because weight we are taking. And this weight is what? This weight is the array. This weight is the array. So that means int weight. We are taking this as an array. Then same as that for here also, it will be int value, means this array. And this will be int n. Okay. So this is the function, and this function declaration is what? That's how the function is declared. And this function is used for what? This function is to find the maximum value that can be put in the knapsack of the capacity. Let's say I use the comment line for your users, then it will be easy for you to understand. Let's say I use the comment. It's the comment I will use. This function is used for the, this function to find the maximum value. Function to find the maximum value that can be put in a knapsack. In a knapsack of capacity W. Okay, so it is defined that this is the function to find the maximum value that can be put into the knapsack of the capacity, put in a knapsack of the capacity. So now we will declare this function. So inside this function, what we will do inside this function, Inside these functions, we will use two conditions. So the first condition is if n equal to 0 or equal to 0 or w equal to 0. So first condition will be if n equal to 0 or w equal to 0. That means number of items. If the number of items is 0 or the capacity of the knapsack is 0, that means we will return 0 because there is nothing. We cannot perform anything. So that's why we will return 0. That's why we'll return 0. Or we name it as the, let's say, this is the best case. This is the best case because if there is no item present or the capacity of the bag is 0, then what we will return? We didn't able to return anything. So that's why we will return 0 in that time. The next case is what? The next case, first I will write the comment. So in the next case, if the weight of the nth item, let's say if the weight of the nth item, if the weight of the nth item means the nth element or the nth item that is present is more than the knapsack, is more than the knapsack capacity, knapsack capacity W. So that means the nth element we are taking, that n item is more than the knapsack capacity W. Then what we will do if the weight of the nth item is more than the knapsack capacity W, that we will perform if, let's say, the condition we will write. So this condition we have to write that weight n minus 1, this n minus 1 is greater than W. That means the nth element, if weight n minus 1 greater than W, that means nth item is greater than, nth item value is greater than the weight of the capacity of the knapsack. Then what we will do? Then we will return, this function. This function will again return knapsack, and here it will be W weight. So W, then this array will return weight and value, and here it will be, instead of n, it will be n minus 1. Okay, so it will be n minus 1. So W weight value n minus 1. That means this nth item cannot be added into the knapsack. This nth element or the nth item cannot be added into the knapsack. So we will write that this item, if this we return, that means this item cannot be included. This item cannot be included into the optimal solution. Included into the optimal solution. Optimal solution. That means this item cannot be included. That's why it is saying that if the nth element is greater than the weight of the capacity of the knapsack, then this item cannot be included into the optimal solution. And in this time, it will return the function with the arguments W, weight, value, and n minus 1, because n element we cannot include it. So that means this is again the recursive process. It will go on. This will be the recursive process. And else, is if this is false, then else condition, that means we can include it into the bag or we can include it into the knapsack. Then what condition we will see? The condition we will see, else it will return that the item can be included into the bag. Maximum of between two values, maximum between the nth element should be included. So what condition it will choose? The nth between maximum value between the nth element can be included or the nth element cannot be included. Between them, the maximum value it will choose. So that means max, it will be max, it will be value maximum between, we will see value maximum between value n minus 1. That means this is the first I am writing the nth, omitting the nth element. We can say including the, we can say maximum between the nth element. So value n minus 1 plus it will be knapsack, it will be knapsack. And we already seen that if the weight, the nth element is included into the bag, if the nth element is included into the bag, that means that weight we minus from the, that weight we minus from it. So this is the first, if the nth element is added, then it will be minus from the capacity of the bag will decrease. So that's why this is W minus weight n minus 1. That means this first time maximum between n element that should be added or the nth element we cannot include into the bag. Between them, the maximum value we will choose. So first time we are seeing that it is the maximum, this is the nth element we can choose. If the nth element we choose and put into the bag, then it will become what? The value will be n minus 1, and the knapsack, in the case of knapsack, the weight will what? The weight will decrease because the particular weight of that element, that particular weight of that element will be subtracted from the capacity of the knapsack. So that's why this is doing that W minus, W is the weight of capacity of the knapsack, and this weight n minus 1 is the particular item's weight. So this particular item's weight will be minus from the capacity of the knapsack. So that means the capacity will decrease. So this is the thing we are doing. So after that, we will weight n minus 1. After this will be weight n minus 1. Not, sorry, this will be not n minus 1, the particular item's weight, then the value, that means the profit, and n minus 1. Okay, so this is the first, and the next condition will be this. The next condition will be this. So that means we will choose it and put it here. Okay. So this is the next condition. That means maximum between the nth element choose to put into the bag or the element that cannot be choose to put into the bag. Between this, the maximum value we will choose. This between them, the maximum value we will choose. This is the condition. This is the condition of it. So like this, the knapsack condition, we can say this is the knapsack function we have declared. This is the knapsack function. Now, here we have written the max.